Before we begin this month's Mastertech, here's a summary of what you'll see in the tech news accompanying this program. For one thing, you'll find an article about the 1998 Mastertech Gold Tool Award. The news also contains a story about last year's Chrysler ASE Technicians of the Year. Plus, there's the monthly column listing the most recent MDS2 software updates and another column with tech tips. So be sure to check out this month's news. Maintaining a good seal between the cylinder head and engine block has always been a critical part of engine service. With the increasing use of aluminum cylinder heads and their special sealing characteristics has come a new type of head gasket, multi-layer steel, or MLS. Welcome to this month's Mastertech. In this program, we're going to take a look at cylinder head sealing. Some of the information, such as that concerned with diagnosing a leak, applies to any cylinder head. Other information will focus on the special concerns associated with aluminum cylinder heads and multi-layer steel gaskets. In other words, the purpose of this program is to familiarize you with the practices and procedures associated with servicing aluminum cylinder heads with the new multi-layer steel gaskets. After viewing this program, you should be able to describe special sealing concerns associated with aluminum cylinder heads and multi-layer steel head gaskets, techniques you can use to check for a leak between the cylinder head and engine block, appropriate cylinder head removal and inspection procedures, cleaning methods that will not damage cylinder head surfaces, proper gasket and fastener installation procedures, and proper follow-up to ensure a good repair. In this segment, we're going to look at some of the characteristics of aluminum cylinder heads and multi-layer steel gaskets that affect sealing. Let's start with the cylinder heads. First of all, cylinder heads that are made of aluminum have roughly twice the expansion rate of cast iron cylinder heads. The result is greater expansion and contraction as the engine heats and cools, and a corresponding need to maintain a good seal with fasteners that have been tightened in the proper sequence to the correct torque. Also, aluminum's expansion rate combined with its flexibility means that overheating is more likely to result in warpage and a seal leak than with cast iron cylinder heads. As a result, it's particularly important to follow the recommended procedures when servicing the cooling system to track down and correct the causes of engine overheating and to carefully examine the cylinder head on an engine that has overheated. The fact that aluminum is softer and more flexible than cast iron also means that incorrect removal, cleaning, and installation procedures can damage it, and that you'll need to examine it closely for cracks and corrosion. Of course, on the plus side, aluminum cylinder heads are much lighter than those made of cast iron, resulting in significant weight savings. In the past, composite and graphite head gaskets have provided effective sealing for aluminum cylinder heads. Composite gaskets use a fiber facing on a steel core. Graphite gaskets also use a steel core, only with a graphite facing. Changes in gasket technology have led to the increasing use of multi-layer steel gaskets for a superior seal. As its name implies, the multi-layer steel gasket uses several layers of stainless steel. A thin rubber coating between the layers provides sealing. Currently, multi-layer steel gaskets are used in all 2-liter and 2.4-liter four-cylinder engines with rear exhaust, and they replace the composite gaskets used for servicing these engines in previous model year vehicles. You'll also find these gaskets in 2.7-liter, 3.2-liter, and 3.5-liter aluminum block V6 engines, and in the 4.7-liter V8 engine used in Grand Cherokee. The Viper V10 engine also uses this gasket design. The multi-layer design has a number of advantages. For one thing, because of its uniform thickness, the MLS gasket is less likely to cause bore distortion after the cylinder head is installed. The multi-layer steel gasket is also more resilient than other gaskets. So, after being compressed, it bounces back to form a good seal. Because it provides an almost seamless transition from a cylinder head to block, a multi-layer steel gasket also contributes to lower emissions. While the multi-layer steel gasket is designed to provide a superior seal, it is not a cure-all for cylinder head or block imperfections. And, as we'll see later, you still have to inspect these components thoroughly to ensure that they can provide a good surface for the MLS gasket to seal against. Now, try this review question to check what you've learned so far. You may want to pause the tape to discuss the question as well as the material in this segment before answering. Which of the following describes the properties of aluminum versus cast iron cylinder heads? A. Aluminum is softer. B. Cast iron expands at twice the rate. C. Aluminum is more rigid. D. Cast iron is lighter. The answer is A. Aluminum is softer. For that reason, you'll have to be particularly careful when servicing aluminum cylinder heads. When diagnosing symptoms that could be caused by a cylinder head seal leak, it's important to make sure that the cylinder head seal is in fact the cause of the symptom. Both oil and coolant can travel from external leaks in other locations to the cylinder head seal area. So it's critical to check all potential leak sources. In the case of oil leaks, that means such items as the cam sensor seal, the cylinder head cover gasket, and the PCV connections. In cases that are difficult to diagnose, you may need to use dye that is sensitive to ultraviolet light to pinpoint the source of the leak. Instructions for conducting this and the air leak detection test are located in Group 9 of the service manuals. They will also be covered in an upcoming Mastertech, so be sure to watch for it. In some cases, such as when a warm engine emits large amounts of steam from the exhaust, it's pretty obvious there is an internal coolant leak, possibly from the cylinder head seal into one or more cylinders. Another obvious sign of an internal leak is spark plugs that are fouled with coolant. When the leak is not quite so obvious, you may need to pressurize the cooling system to check its integrity. You may also need to check the coolant for oil, or you may need to use a chemical test to check for exhaust gases in the coolant. The point is to determine, based on the symptoms and the tests, exactly what, if anything, is leaking and where it is leaking to. Once you've established the approximate location of an internal leak, you still need to disassemble engine components and visually inspect the area to confirm the cause. Remember, a leak between coolant and oil passages, or between these and the combustion chamber, is not necessarily proof that the cylinder head seal is at fault. In addition to the cylinder head seal, a crack in the cylinder head or in the block are also possibilities. Also, keep in mind that if the cylinder head seal did fail, a complete diagnosis involves finding the underlying cause of the failure. By underlying cause, we mean cooling system problems, which lead to overheating and resulting head warpage. Combustion problems, such as pre-ignition or detonation that damage the cylinder head gasket, are another underlying cause of cylinder head seal failure. Unless these problems are corrected, you're likely to see the same vehicle back again with another cylinder head sealing problem. We'll talk more about these later in the program. It's also important to use appropriate cylinder head removal and cleaning procedures to avoid creating new sealing problems. These procedures are the subjects of the next part of this program. Before we move on to those, however, try this review question to check what we've looked at in this segment. It's a good idea to pause the tape to discuss the question and review the material in this section before proceeding further. Which of the following can be used to confirm an internal engine leak? A, an inspection of the spark plugs. B, a cooling system pressure test. C, a chemical test for exhaust gas in the coolant. Or D, all of the above. The correct answer is D. All of these methods can be used to confirm an internal engine leak. Once you've reached the conclusion that a failure of the cylinder head to seal against the block is a probable or possible cause of the symptoms, you'll need to disassemble and clean engine components so you can inspect them. At this point, it's important not to create any new sealing problems by careless removal and cleaning procedures. Care and cylinder head removal starts with unbolting the head using the reverse of the tightening sequence. The general pattern is from the outside in. Loosening the fasteners in this manner reduces the chance of aggravating any warpage that may already be present. When cylinder heads are stuck to the block, take care not to damage the sealing surfaces by prying on them. And keep in mind that some cylinder heads, such as those on the 4.7-liter engine, use smaller fasteners in areas that may not be obvious. In other words, make sure that all the bolts have been removed. Once you have removed a cylinder head from the vehicle, try to avoid placing it on its sealing surface, and don't slide the sealing surface over a bench top. Doing so can easily damage an aluminum cylinder head, particularly when the bench top is metal. In cases where a head does have baked-on gasket material or deposits, you'll need to use cleaning procedures that will not damage the sealing surfaces. Under no circumstances should you use metal tools on aluminum cylinder heads. Such tools will damage the aluminum and prevent the cylinder head from sealing. A recent technical service bulletin details the accepted cleaning procedures for aluminum cylinder heads. TSB 9598 is aimed at recommended procedures for installing a multi-layer steel gasket on 2-liter single overhead cam engines and 2-liter and 2.4-liter dual overhead cam engines. However, the cleaning procedure applies to any aluminum cylinder head. Begin by removing as much of the gasket material or deposits as you can with a plastic scraper. As you perform the following cleaning procedures, periodically inspect the head for damage that could prevent it from sealing when it's reinstalled. There's no point in continuing to clean a cylinder head that is too heavily damaged to seal properly anyway. Also, if the symptom was a coolant leak into a combustion chamber and a cylinder head gasket looks intact, you may want to send out the cylinder head at this point for pressure testing, because the cause may be a crack in the cylinder head. In some cases, you may need to use a gasket remover solvent along with a scraper to clean the head. In many cases, especially when the previous gasket was a multi-layer steel design, you may be able to clean the sealing surface using the methods we have discussed so far. In other cases, you'll need to use more aggressive techniques. To remove any remaining material on the cylinder head sealing surface, you can use a white plastic 3M Rolock bristle disc. Note that this is a particular type of 3M disc that uses plastic bristles, and it should not be confused with 3M abrasive discs that could damage the cylinder head. To obtain the best results, you need to use the bristle disc at close to the maximum operating rotation speed. You may need to use a die grinder or moto tool to obtain these speeds. Also, when using the bristle disc, do not allow it to contact the sealing surface for any longer than necessary. Or you could, for example, round out the edges of coolant passages and undermine sealing. In extreme cases, you can use a yellow 3M Rolock bristle disc to remove any remaining material. Keep in mind, however, that you'll need to take even greater care when using this disc, or you will damage the cylinder head. You can use the same methods to clean other engine components, such as the sealing surfaces of the block and manifolds. However, if the component is aluminum, you'll have to use the same care as with aluminum cylinder heads. As part of the block cleaning procedure, you should always use compressed air to blow any foreign material out of the bolt holes. Then, check the holes for any remaining foreign material, corrosion, and damage. If the bolt holes are partially filled with foreign material, you can damage the block when installing a bolt. If the threads are corroded or damaged, it may not be possible to obtain the proper torque on the cylinder head bolts. Once you've cleaned the cylinder head and other engine components, you can inspect them for damage or wear. That's the subject of the next part of this program. Before we move on, however, try this review question. Which of the following can be used to clean the sealing surface of an aluminum cylinder head? A, metal scraper, B, wire brush, C, plastic scraper and gasket remover solvent, or D, sandpaper? The correct answer is C. You can use a plastic scraper with or without gasket remover solvent, and you can carefully clean these heads with a white Rolock bristle disc, but you should never use metal scrapers or any other tools which could damage the surface of an aluminum cylinder head. Thoroughly inspecting cylinder head components to see if they need to be replaced or brought back into specification is a critical part of cylinder head gasket service. If a part is outside of specifications or damaged in some way, you simply can't count on it providing a good seal. Let's begin with cylinder head bolts, which are reusable, but only if you've inspected them using the procedure in the applicable service manual. You can check the head bolts for stretch with a straight edge. If the threads are not aligned with the edge, the bolt has stretched and must be replaced. Corrosion and thread damage are additional reasons to replace head bolts. You'll also need a straight edge along with feeler gauges to check the cylinder head sealing surfaces for flatness. In general, the check involves positioning the straight edge parallel to, at right angles, and diagonally to the length of the cylinder head. Pay particular attention to the areas between the bores, since warpage in these areas is likely to result in a failure to seal. The service manuals contain specifications for cylinder head flatness, so be sure to consult the one for the engine you're working on. You can use the same method to check the block deck for flatness. In some cases, if the warpage is relatively minor, you can consult your local machine shop or cylinder head reconditioner to bring it within specs. Keep in mind, however, that machining affects a number of other components, such as the valve train and manifolds, so be sure to follow the recommendations and the appropriate service manual concerning machining cylinder heads and blocks. Besides warpage, there are other problems that can affect sealing, such as corrosion, pitting, and gouges on the sealing surfaces. Pay particular attention to the areas between combustion chambers and around coolant passages, since these are most likely to leak if there is severe surface damage. And don't overlook the corresponding areas on the engine, particularly if it has an aluminum block. Cracks are another problem you'll need to inspect the cylinder head and block for. Pay particular attention to the areas around valve seats. Once you're sure you have a cylinder head and block that will seal properly with the new gasket, you are ready to reassemble the engine components. Before we move on to that part of our program, try this review question to check your knowledge of inspection methods. Technician A says that cylinder head bolts are not reusable. Technician B says that you need to measure each bolt's diameter with the dial caliper before reusing it. Who is correct? A only, B only, C, both A and B, or D, neither A nor B? The correct answer is D. You can reuse cylinder head bolts provided you check them for stretch by placing a straight edge against the threads and looking for gaps. When installing a new gasket on the cylinder block, there are a few things to keep in mind. For one thing, some gaskets, such as the multi-layer steel replacement head gaskets discussed in TSB 9598, must be coated with Mopar aerosol gasket sealant or its equivalent before installation. Some sealants can damage head gasket coatings, and not all gaskets use a sealant, so be sure to check the instructions for the gasket you are installing. The next thing to be aware of when installing a new gasket is that it's possible to install some gaskets incorrectly. Make sure the part number on the gasket is facing up and the oil holes aligned. Installing a gasket incorrectly can route oil to the wrong passages and cause severe damage to the engine. And on gaskets for V-type engines, be aware that some applications use right and left gaskets that should not be switched. Earlier we described how to inspect cylinder head bolts to make sure they are reusable. Once you've replaced those that are not, lightly oil the bolt threads prior to installation. Do not squirt oil into the bolt holes. Bolts that have a Dacrament coating, such as those used on Viper, and bolts that you need to apply thread sealer to should not be oiled. When placing the head bolts in their proper positions, keep in mind that some bolts may be shorter than others. For example, on 2-liter single and dual overhead cam engines, the bolts at the corner locations are shorter. On some engines, some of the cylinder head attaching bolts are smaller and in locations that may not be readily apparent. On the 4.7-liter engine, there are 4 smaller bolts at the front of each cylinder head. These bolts are also special because instead of being lightly oiled, they must be coated with thread sealant prior to installation. On the 2.7-liter engine, there are 3 smaller bolts at the front of each cylinder head. On all engines, tightening the cylinder head bolts must occur in a numbered sequence, a sequence that generally works outward in both directions from a starting point in the middle and that requires multiple steps to achieve the final torque. On the engines we've been discussing, there is an additional step that involves tightening the bolt an additional 90 degrees. This method of tightening the bolts is referred to as the torque angle method. Let's look at this sequence on Neon with a single overhead cam engine. The first step is to tighten all the bolts to 25 foot-pounds using the sequence specified in the service manual. Then, tighten the bolts in sequence to 50 foot-pounds. The third step is to go over all the bolts in sequence again with the torque wrench set at 50 foot-pounds. The final step is to turn each bolt an additional 90 degrees using the same sequence. Notice that we do not use a torque wrench for this final step. That's because a torque wrench handle can move without actually turning the bolt. Be sure to consult the appropriate service manual and relevant TSBs for cylinder head bolt installation procedures and specifications. While we're on the subject of torque, you need to be aware of a change in specifications for dual overhead cam 2-liter engines being fitted with a multi-layer steel head gasket. This change is spelled out in the TSB we've been referring to, 9598. As before, the corner bolts are tightened to 20 foot-pounds during the first step. On the second and third steps, however, the bolts are tightened to 35 foot-pounds. The rest of the tightening procedure remains the same. Oh, and by the way, the smaller bolts at the front end of the cylinder heads we've been talking about do not use the torque angle method for tightening. See the appropriate service manual for the correct torque specifications for these bolts. Next, we're going to look at some follow-up procedures that help ensure the new gasket can do its job. First, though, try this review question. It's a good idea to stop the tape to discuss the question and answers as well as the material in this segment before moving on to the next segment. Which of the following statements about cylinder head installation are true? A. Never use spray sealant on the gaskets. B. Oil all cylinder head bolts. C. Tighten all bolts an additional 90 degrees as a final step. Or D. None of the above. The correct answer is D. None of the above. Some gaskets do use spray sealants. Not all cylinder head bolts are oiled, and not all cylinder head bolts are tightened an additional 90 degrees. It doesn't do much good to replace a cylinder head gasket if the conditions that caused it to fail are still present. If engine overheating caused the cylinder head or block to warp, you're going to have to discover the cause. Of course, you'll want to start with the cooling system by checking for anything that is preventing the system from doing its job. Is the system leaking? Are the cooling fans doing their job? Is the thermostat faulty? Is the water pump circulating coolant? Is there a blockage in the radiator or coolant passages? Besides warpage, overheating can also cause detonation and pre-ignition that can damage the cylinder head gasket. Besides overheating, there are a number of other areas you'll need to examine if detonation or pre-ignition caused the cylinder head seal to fail. Was the owner using low-octane fuel? Is the NOx sensor working? Is the EGR operating? Are there carbon deposits on the pistons? Is something leaning out the fuel mixture? One condition that can cause a cylinder head seal to fail is also one that you'll need to be aware of when you refill the cooling system. I'm talking about air pockets that can cause localized or general overheating. To avoid these air pockets, you should always follow the recommendations in the appropriate service manual for cooling system refilling. Some of the procedures specify the use of special tools and bleeding devices to avoid trapping air in the system. For example, when refilling the cooling systems on vehicles equipped with 2.7, 3.2, and 3.5 liter V6 engines, you'll need to install a special funnel fill tool on the coolant bottle. Refilling these and other systems may also involve the use of bleeder screws or plugs that help prevent air pockets. The technical service bulletin we have highlighted in this program also specifies an additional step to help ensure a successful repair, and that is replacing the cam sensor seal. Using the old seal is an invitation to a leak, one that could be difficult to distinguish from a cylinder head seal leak. When you've finally gotten the engine back together again, a final step is to verify the repair by running the engine and keeping an eye out for evidence of leaks, both external and internal. You may need to test drive the vehicle before you can be sure that the leak has in fact been fixed. The coolant level may drop as any trapped air works its way out of the cooling system. If this happens, be sure to top off the cooling system and run the engine again to check for drops in coolant level that may indicate a leak. Now that we've covered follow-up and verification, try this final review question. Technician A says engine overheating can cause warpage that can cause the cylinder head seal to leak. Technician B says that overheating can cause pre-ignition that can cause the cylinder head seal to fail. Who is right? A only, B only, C, both A and B, or D, neither A nor B? The correct answer is C, both A and B. Engine overheating can cause not only head warpage but pre-ignition, which can damage the cylinder head gasket. And that brings us to the end of this Mastertech program on cylinder head gasket service. Be sure to join us next month when the topics will be the MDS2 and the 24-valve Cummins diesel engine.